Hello guys, welcome to the knowledge domain, the concept of life sciences and biotechnology. This is a lecture series where we are focusing on the animal behavior. So animal behavior or the ethology is a subject. Like in all sciences, every question can be studied using the conceptual, theoretical and the empirical approaches. So in the conceptual approaches, it is the integrating formally disparate and the unconnected ideas and combining them in the new cohesive way to make advances in a very simple word. They are the unconnected dots or the scattered dots and as a ethologist or animal behavior naturalist, we have to connect them to get an information out of it. So natural history and the experimentation play a role in the concept generation. Keen selection is one of the concepts. In that, expanded the bounds of the classic natural selection model. The natural selection favors behavior that increase the reproductive success of individuals. Increase the reproductive success of those individual close genetic kin. So these close genetic can be its own offsprings, its grand offsprings, as well as the other members of the same populations. So Hamilton, he made a concept called the fitness. So this is a variable. Fitness is a variable. It can be direct fitness, indirect fitness. Okay. So what is direct fitness? Direct fitness is the number of the viable offspring produced plus any effect that individual one might have on the direct descendant of its own offspring, as well as on its grand offspring. So the activity or the change in the behavior of individual one, how it is helping in increasing the reproductive success of its own, in producing the own offsprings as well as in producing its grand offsprings. It is directly related to the family lineage, that is a direct witness. Where the indirect witness is how the individual one activity is increasing the reproductive success of its genetic relatives of that population, but not from the family. Okay. So these actions indirectly get copies of the individual one genes into the next generation. And if the character is or the behavior is that is transferred to the next generation, only it has role in the natural selection. Okay. So the addition of the or the sum of the direct witness and the indirect witness result in the inclusive witness. So one of the example is the Mexican jay. So we'll study we will understand the inclusive witness in case the Mexican jay. That is the number of offspring it has, the individual one, plus the fraction of the number of the offspring it helps to a relative to reach. So how it is means increasing the reproductive success of its own by making its number of the more offspring to survive, plus how it is helping its relatives in making viable offspring of its close relatives. So that is the inclusive fitness, its own plus how it is helping, to what extent it is helping in raising the offspring of its close relatives. Next is the theoretical approach. Next is the theoretical approach. Ethology's understanding of how natural selection operates on animal behavior was greatly advanced with the appearance of a sophisticated, usually mathematical models of the evolution of the social behavior in animals and humans. So theoretical approach to animal behavior, generation of mathematical model of the world. So when we say theoretical approach, means mostly it is related to generating some sorts of the mathematical models. So we'll study the foraging related questions as a theoretical approach. That which food items would an animal add to its diet under what conditions? So one of the example of studying is the optimality theory. In this, there is a best or the optimal solution to a particular problem. There are certain constraints exist in a system. This is an example, value of the fawn, this cheetah. So whether the fawn will be added in the diet of the cheetah, that is calculated by using this formula. value of this fawn equal to lambda fawn into energy that fawn will give to the cheetah divided by lambda fawn plus h of the fawn. So what is h? H is the handling time and lambda is the encounter rate. Okay. So the decision to add certain prey types in the forager diet does not depend on how often a predator encountered that prey. So how much the hunter is to what frequency encountering prey. Like for the tiger, the preferred choice of the prey is the deer, then the second is the sambar. So it is not on how many means the other prey like the rabbit or any other animals present in like humans, it is encountering. But how often it is encountering more preferred prey like the deer or the sambar. That determines whether that prey will be added in the diet of the tiger or not. Similarly for the cheetah. So it is not on how often a predator encounters the prey, but on how often it encounters more preferred prey types. That determines whether that prey is included in the diet or not. Next is the empirical approach, in which there is the gathering of data and drawing conclusions, generating new testable predictions. This empirical approach is further divided into observational or the experimental studies. Observational work involves watching and recording what animals do. Recording because without attempt to manipulate or control any ethological or the environmental variable. We do not want to manipulate, we just want to make hypothesis and prove it based on the observation. Okay. So this is an example of the habitat, forest, mangrove, grassland. In these habitats, we will study the birds, means the behavior. So the birds are the rufous tree found in the forest, brown wing and the kolar red kingfisher found in the mangroves, great Indian bustard found on the grassland. So they will be discussed at the birds in this discussion. So we went to the habitats from the 9 a.m. to 5 p.m. and we start observing foraging behavior, means collecting, means food by natural way, encounter with the predators, these birds, how many times it is encountering predators, and the feeding of the nestlings. So then we hypothesize based on the observation that birds seems to make few foraging bouts when predators are in the vicinity. So when there are the predators in the surrounding, but don't go out for the foraging. This is our hypothesis. We need to prove it. The relationship between foraging and the predation pressure. That is the question. We need to find out the relationship. So how much, so to understand this or to get the answer of these questions, we need to know how much food the bird eat and how many predators I can spot in that area. So is it fair to say that increased predation pressure cause decreased foraging? We haven't calculated this. No. We cannot speak to the subject of what caused what, the causation. Correlation does not equal to causation of the mechanism. That is to understand the behavior. In one of my previous lecture, I have discussed there are the four questions of that inversion to understand the animal behavior. One of them is the causation of the mechanism. So in this observation, till now we don't know what is the cause of outing of the birds for the foraging in the presence of the predators. So to understand that, it might be that some other variable is causing both greater predation pressure and the less birds foraging behavior. They are related, inversely related, the presence of the predators and the birds foraging behavior. But till now we haven't studied it in that context. But we observe that when there is a prey found in the surrounding, the bird usually the frequency of the foraging is less. So this can be from the other variables, like when there is a temperature rise, the bird's predators becomes more active, but the bird themselves become less active. So this the variable is the temperature is regulating the two activity. But hence in the presence of the predator, there is a less bird activity. But predation pressure and the foraging would still be correlated. Okay, so predation is there and foraging. In that cases also, if there are more predators, there is the less foraging, it is still possible. Still they are correlated because of though it is related for the temperature. But former would not be seen as a causing the latter. But till now we haven't proved that when there is a prey, means the predators are having the less frequency of the foraging, but be associated with the change in the weather. It is related to the temperature. Okay, to understand that we need to do an experiment. So we might experimentally manipulate our system. So we have two systems, area one and the area two. So we might, for example, experimentally increase the number of the bird predator by manipulating to check whether the predation is actually regulating the foraging behavior of the bird or not, the frequency. So in the area one, there are the more prey are present, we will manipulate it, but not in the area two. So how birds foraging is affected in this population, we will study it. So the trained predators or the simulation was created in the area one to actually simulate that there are the more prey available in that area. But we don't do that in the area two. So birds foraging behavior decreases in the area one. This is the observation, but not in the area two. So in the beginning, both area were same, but we simulated area one are like there are the presence of the prey. So this is manipulated. So only one variable is changed. That is the and it seems that in the area one there are the more prey. That is our manipulation. And we observe that increased predation pressure caused decreased foraging in these birds. So we found that in the area one there are the less frequency of the foraging, whereas in the area two there is no change in the frequency. So when we created the presence of the prey or we created this environment, we found that the bird's frequency of foraging is decreasing. So from this experimentation, when we change only one variable, that one variable is the change in the predation pressure. Though it may be actual, it may not be actual, or it may be simulated, but that is experimentally controlled to know in the two similar settings when there is a perception or a presence of the prey, the foraging activity is decreasing. So from this, it is concluded, or we make this observation, or we reach this conclusion that the presence of the prey population results in the decrease in the foraging activity.